Great questions, fam. I appreciate it. We have no questions about anything that's up here.
Oh, yeah, what about the negative 4 you were telling me about?
The what?
Negative 4. I don't get there.
Well,
I don't see a negative.
No, I don't have a negative 4 up there. What you had written down at one point was 6 minus 10.
Yeah, I'm trying to show you how you could get it.
6 minus 10 is negative 4, not 4.
How?
Pick up that calculator, type in 6 minus 10.
It'd be 10 minus 6 equals 4.
Hold on.
Because
I don't know. Oh, okay. Well, why?
Huh?
Why?
Why is it negative 4?
It's because you're going backwards with it or whatever?
Yes. When you're starting at 6 and you're going backwards 10. When you go backwards 10, you get to negative 4. If it was 10 minus 6, 7, 8, 9, 10, and then you go backwards 6, 1, 2, 3, 4, 5, 6, you end up at 4. But it's important to recognize that it's 6 minus 6, 10 minus 6, right? Because that 6 minus 6 is 0. We use the addition property of equality, which tells us to subtract it on both sides. And what is 0 plus x?
X.
X, right? So x equals 4. Now, I do not want any of you to forget, because I feel like a lot of students just get in the habit of solving an equation using the inverses without thinking about what that means. What do we mean x equals 4?
4.
Huh?
X is 4.
But why is x 4? Why is that what it equals to?
Because it's the solvent you need to finish the problem.
Pretty sure solvent is a chemical thing. I believe it's the thing that what's the other one? There's solvent and...
Covalent.
No. Well, the solution is what is created when you put a solvent with the solute. The solvent is the thing that dissolves a solute and you get a solution.
I knew that.
I don't think you did. How about this? X equals 4. So let's substitute 4 in for x. What did that value do to that equation? Makes it equal. There's a T word that we use.
True.
Makes it true. The solution, and you need to hold on to this because this is where we'll pick up after spring break. The solution makes the equation true. It can also make inequalities true. I know that you are used to saying, hey, the solution is the answer. That is not true. Your answer can be wrong. The solution is always correct because the solution makes the equation true. That's the point of a solution. When we say x equals 4, why does x equal 4? Well, because if I were to plug in a 7, does 7 make that equation true?
Yes. No.
Not even remotely. If I plug in a 3, does a 3 make that equation true?
Yes. No.
What is the only thing that makes that equation true?
4.
That's what we mean by solution. And it's important to recognize that those inverses allow us to get there more easily. But the focus for us right now is this idea, number 5. What questions do we have? Notice I've given 3 different equations possible. There are more than just these.
Mine's not up there.
What'd you write?
F of x equals 1.7 plus 2, plus 1.2 x minus 1.
Like that?
Yeah.
You're very close.
No.
That's this one, 1.2 times x minus 1 plus 1.7. You took the idea of I'm starting at 1.7, I'm adding 1.2 x minus 1 times, but notice what form of the equation of a line did I use?
Point slope.
I used a point slope. I have a point, and I have the slope, the additive rate of change. Right? Over here, which one did I use?
Slope-intercept.
This one? 2.9 is my y-intercept?
Just looks like.
That looks like slope-intercept, y equals mx plus b.
Yeah. Equals that, I think. Line. Slope and point slope.
Thank you, that's another point slope, isn't it?
That was in slope-intercept.
Because hey, look, just so you know, I don't know what, but they called Alan down for a meeting.
Okay,
They had him go ahead and bring the stuff.
interesting.
Yeah. Notice it's another point in the slope though, right? So is there more than one option for point slope?
No.
These aren't both acceptable?
No. Yeah. Sort of.
I mean, notice I used this point, and I used the slope of 1.2. Here I used this point, and the slope of 1.2. Could I have used this point?
Yes.
So I want you to remember this. Each of these are different equations, but they're representing the same function, which means that those equations are what? They look different, but they're effectively the same?
Equality. That's close, isn't it?
It's close.
Inequality. Equivalent.
Equivalent.
Good sort of.
Even your equation is equivalent to those two. You don't have to have exactly the same one that we have, but they are equivalent. Good conversation, okay? Other 4 people, we have 4 people in this class, or 4 other people in this class. We go with these ideas, we take any notes, learning, staring off moodily.
No.
Huh?
I'm looking at the board.
And you go with these ideas,
Yeah.
okay?
I was understanding it myself. I was seeing the rate of change in 1.2.
Good.
Yeah.
And it is important to notice that because the rate of change is 1.2, it's additive, so what type of function is it? Linear.
Yeah.
Now, why did I say that this is continuous?
I mean, because you keep adding something, yeah, 1.2 at a time.
Okay, but if I were to
You
do,
can keep going with it.
Who did you do? X plus.
you know, Mona, you could complain about it some more, but it's going to be the same temperature,
Why?
because that's the temperature of my classroom.
Feels delicious.
I want you to notice I'm adding 2 every single time there. Right? Is that continuous?
Yeah.
We're not getting anything in between.
I'm not getting anything in between, which means those are isolated points, which would make it
Discrete.
discrete. So you can't just say, hey, you're doing the same thing every time. A linear function always is adding the same thing every time. An exponential function is always multiplying by the same thing every single time.
But it's not, it's always the same thing, but it's not consistent. Like that's consistent every week. It's 1.2 every week.
But all you know right now is the weeks. Do you know that it's growing in between that time?
It gotta be.
How do you know?
The half a week is like, what, 0.6? Since it's 1.2. I guess.
So, but like here's the thing you have to recognize, and this is what you need to think about. Is there growth happening between those weak markers?
Yes.
Yeah.
Okay, that's what you have to be able to explain. All you were saying is we're constantly adding by 1.2. That's what makes it linear. That's not what makes it continuous. That's discrete because there's nothing happening in between. But here, if I'm talking about a plant growing, it's not just gonna like magically shoot up 1.2 centimeters at the end of the week. It is gonna grow the entire time between there. But that's the language you have to use, otherwise you do not have the language down correctly. You will lose points on the test and things like that. Okay? So linear, continuous, oh, by the way, this